SwayamPrabha. Digital India. Educated India.
Hello friends, so far we have learned about various sensors and how they are used to calculate different parameters such as speed, your altitude, what will be the pressure, your position, and we saw the working principle of different sensors. Now today we will be using a sensor to acquire data, and we will be doing this using a Arduino board. Now this is a simple board. It has a Atmega 3 to 8P microcontroller. It has 14 digital pins, 6 of which are for PWM output. It has 6 analog input pin. It has a flash memory of 32 kilobyte and a clock speed of 16 megahertz. Now in order to acquire data for acceleration and rate gyros, the sensor which we will be using is MPU 6050. Now this is MPU 6050. It has accelerometer and rate gyros. Now you can see the full detail of this sensor from datasheet, and this is a summary of what will be the range and sensitivity of rate gyros and accelerometer, what will be supply voltage and size of this sensor. Now first part of this is to make connection in order to acquire data. So simple connection between MPU 6050 is we have to use I2C protocol, and connection is as follow. MPU VCC will be connected to 5 volt of Arduino Uno. Your SCL will be connected to analog input A5. SDA will be connected to analog input A4, and your interrupt signal will be connected to digital output pin. Once this connection is made, you can power your Arduino either using a USB, or you can use an external power supply to power up your Arduino board. Now in order to acquire data from sensor, you have to use an IDE or some platform to write code. In this case we will be using Arduino IDE. So just open Arduino IDE, and you can connect Arduino using USB and make sure that right COM port is selected. In my case it is COM6. Now we'll be seeing there are several examples already mentioned in this IDE. We'll be taking some examples related to MPU 6050. Now before taking data from your sensor, first step is to calibrate it, or you know the offset of this sensor. So there is an inbuilt program in the example which is known as, you can see as IMU0. Just you have to click on that and a program opens. This program is made by Jeff Roberg, and it will calibrate the offset of your MPU 6050. You have to place your MPU 6050 on a horizontal surface, and first we'll compile this code. Click on compilation. It will compile and give you if there are some errors in this code. Now compilation is done and it shows there are no errors. Once compilation is done, you have to upload this code. Click upload. Once the code is uploaded, click on serial monitor. Here baud rate was 96 00. As you can see from code, the data was been sent at 9600 baud rate, and it will check your IMU device for offset. It has two readings, one lower value and higher value. It will keep on decreasing this interval and give you an offset value. Then you have to wait for 3 to 4 minutes in order to calculate the right offset value for your sensor. Once calibration is done, you will get a message done, and the values for offset in x acceleration will be 7 to 1. In y acceleration it will be minus 660. In z acceleration it will be 1381. For x gyro your offset will be 69. For y gyro it will be minus 5, and for z gyro it will be 30. Not exactly these values, somewhere in between this there is an offset. So once calibration is done, we'll go for another example, MPU 6050 DMP6. Now here this program calculate different values depending on which function you use. Here you have to enter this offset value in order to get correct readings. So this is a code. We'll be seeing output in terms of roll, pitch and yaw. And offset values we have to, which we got from previous example, will be given here. Your x gyro in offset was 69. Your y gyro offset was minus 5. Your z gyro offset was 30. And z acceleration offset we got was 1381. Once these values are set in offset, then you have to click on compile. Here you can see, here serial begins is at 15200 baud rate. So while seeing the output of serial monitor, we'll select baud rate as 15200. Once compilation is done, then you have to click upload. Once upload is done, you have to click on serial monitor, select baud rate as 15200. It will ask you to enter any character in order to start data streaming. So this is your interrupt signal. Click on this bar and press any key and enter, and these are the values of your yaw, pitch and roll. And as you can see, as I tilt my IMU, these values will change. Now these are in terms of number. We don't have actual feeling how your object is behaving. Just you can see that you are getting a yaw of -4 or 10 to 20 degrees, your pitch 3 or 11 degrees, and your roll as 30, 20, 45. Now the limitation of Arduino IDE is that you don't have a graphics rendering. In order to see how graphically your IMU is behaving, you have to use another IDE, which is processing. For that, there is a small modification you have to do in the code MPU6050DMP. Now we were seeing output of readable yaw, pitch and roll. You have to comment this value, comment this function, and you have to use output teapot. Once you have done this, click upload. Once upload is done, click on processing IDE. Now in order to run this program you might need some additional library. Once this processing is open, then there's a small code which we have written. Desktop. IMU dot. This is a small code which will show how your IMU is behaving, and you can graphically see this because this IDE has graphics rendering facility. So we have already dumped a code MPU 6050 DMP6 and we have set output as teapot. Now once this is done, just click on your code and this is the output you will get. Now this you can see as you move your IMU, this cuboid or box will move according to that. So you can actually feel how your IMU is placed, or you can visualize when this IMU is placed in some UAV or some body which is rotating or moving, how your IMU would be feeling acceleration and rates according to that. See, now similar way we'll see how to use angle of attack sensor to get data. The second experiment is to acquire data using angular sensor. As you can see, this is an angular sensor and it has a rotatory control. Upon rotating this control, you will be getting different values. These values can be then mapped according to your VDC voltage, that is from 0 to particular VDC you have to map this rotation. Now once this particular mapping has been done, then you can further map these voltages corresponding to a particular rotation to 0 to 360 degrees. And as you can see in this sensor, it has 3 wires. Now that is signal, VDC and ground. Now connection that has to be made with Arduino board is as follow. This signal pin corresponding will be your analog input A0 and VDC will be 3.3 volts and ground will be connected to Arduino ground board. After that you have to open your Arduino IDE. We have written a small code for this sensor. We'll be explaining you how this code works. Now, as you can see, each code has two sections. One is setup and second is your loop. And further functions can be defined in any of these loops. Now here in this code, now first we have mentioned at what particular port of Arduino board will be taking the input from our sensor. Here we have given A0, that's why we told you signal will be in A0. This is configurable, you can change this analog input port. Now reference voltage is 3.3 volts and full rotation of this rotatory control is 360 degree, hence full angle is 360. Now first in setup, we have seen in previous section also that at what particular baud rate you will be transmitting or streaming data, that has to be mentioned in step setup. Here we are streaming at 9600 baud rate. Now second is your loop. Now in loop you can see we have used a function get degree. Get degree is nothing but here the sensor value, you can see it is reading what is the value it's getting from input port A0. This value is then converted into voltage using this relation. Now sensor suppose value is 400, your reference voltage is 3.3, and 721 is a maximum value which you are getting upon rotating this contact or control switch or this rotatory contact. Once you get that value, you can then map this value to particular degree using this particular set of equation. Using this equation, now this will further give you that degree. And now if you want to set a reference point, say you want to fix this rotatory contact to a particular point that you want to set as 0, so you have to first fix this rotatory contact to a particular position, and then corresponding voltage that you get will be then mapped in degrees. That is, your 0 degree will then represent that particular value, and upon rotating in clockwise or anti-clockwise it will either decrease or increase. In my case, I have mapped it such a way that anti-clockwise rotation will increase my angle in positive, and clockwise rotation will decrease my angle in negative, and it will go from minus 200 degrees to 160 degrees, total of 360 degrees. Now let's compile the program to see if there is any error or not. Now compiling is done, we are not getting an error. Now upload the code. Once the code is uploaded, go to CL monitor, baud rate you have to set, and that corresponding to you will be getting output. See, I told you first you have to set your reference point. I have set my reference point 0 to this particular contact switch, this contact position. Now when I am moving this rotatory contact in anti-clockwise direction, you can see angle value is increasing, whereas that number you are getting, that is decreasing, which is uh, understandable. Here the positive rotation will increase the value, whereas negative will decrease the value of rotatory contact. Now I am rotating it in clockwise direction, and you can see my angle is decreasing, and it won't go beyond minus 200. See, minus 197. After that it has switched to positive value. So this way you can map a particular potential or rotation to corresponding voltage or degrees, and there are a lot of codes available for Arduino platform, and sensors are available. You can use that, learn the code, and these are beneficial when you want to acquire data from small UAV aircrafts, or or some platform where you want to analyze how it's behaving, what its turn rate, what's its pitching angle. So this will be beneficial for you. We'll be sharing this code on the forum, and you have doubt you can ask them on forum, and you can use these type of sensors to design angle of attack sensors, because and this will be aligned with your aircraft. And as this flag will move, or vane type, we have learned in previous lecture how vane type angle of attack sensor works. When this angle of when this vane will move up and down, corresponding to that your angle will be shown, and you can design this as an angle of attack sensor. Thank you.